available from the balance sheet, and how many we have from the income statement? We have about 120 variables from income statement. How about cash flow statement? How many variables we have from cash flow statements? About 35 cash flow statement. So idea here is if you adding all these variables together, we have around like 250 variables available from the financial data. So the idea here is I'm not counting stock returns, right? This is just fundamental data. We have a stock returns. We have a liquidity. We have a trading volume. I'm not counting those, right? I'm not counting those. So what I'm saying is just from the balance sheet, income statement, the cash flow, we have a 250 variables for you to analyze. So if you are professional, if let's say one investor asks some of you, let's say Chao Chu, investor come to you say, hey Chao Chu, there's a huge information here, 250 variables. Can you tell me what I can learn from the 250 variables for the firm? So Chao Chu, that's what you need to do. You need to know how to analyze these variables and generate some useful recommendation for investors, right? And also you should analyze these 250 variables and provide good comments for managers. And that's what we learn. That's what we learn from this class. That's what I want to learn from this class. And how do we do so? How we can actually generate insights from these 250 variables? It's more than 250 variables because we have a stock returns, stock momentum, so it's more than. So how exactly we can do so? How exactly we can do so? Let me share my other screen. So there's a two approach. There's two approach to do so. One approach is you come up with a theory, and then use the theory to test whether the theory, the pattern generated by theory can help investors and managers. That's one approach. Another approach is using machine learning. The machine learning approach is a little bit more of like a high dimensional data process. So basically, you throw in all the 250 variables into the machine learning as an input, and then the machine just learn by itself, just keep training itself and tell you which one, what kind of pattern can help you generate future stock returns. So let me talk about the two approaches side by side so you can see what's the idea behind. So what's the example of theory-driven approach? So what I just talked to you guys now, that's a theory-driven approach. Does it make sense? Because I tell you the primary business, the income from primary business is more persistent than side business income. So we prefer firms income are most from the primary business, not side business. So that's a theory-driven approach because I have that in my mind. I have the theory in my mind. I think the primary business will persist more than the side business. So I prefer firms to have a higher proportional income from the primary business. So this is a theory-driven approach. And later on, the team 4 will present a paper, present the research. That's also theory-driven approach. So in this approach, what we have is you have some theory ahead of the game. You have some like a speculation. You have some hypothesis. You have some theory back up your prediction. So for here, the theory is I believe primary business income is more healthier than other business income. That's the theory, and I use that to test whether firms have more primary business income will do better than firm whose income are from side business. That's the theory-based approach. I use that to have the theory to test that theory is correct. That's one approach. So what's the second approach? The second approach is the machine learning approach. What I do is I put the 250 variables into the machine learning model. And the beauty of machine learning is it's like a human, they learn. So I take an example of we just had the national entrance exam finished, right? Past week, we have the exam finished. So think about it. If you take the national exam again, second time, would you learn something? Would you do better than the first time? Possibly. Okay, you guys disagree. Okay, let's say you do the national exam again in the third time, fourth time, 1,000 times. Would you think after you've done the exam for 1,000 times, would you think you will do better than the first time you take the exam? Would you believe so? Okay, you guys still disagree. Okay, and now I don't know. I don't know if normally, okay, on average, the more you take the exam and you check the answer and you see something is wrong and you review and you come back and forth, normally the learning process will improve your performance on the national entrance exam. Normally. So the machine learning is the idea is the machine can do the same. Instead of human learning, machine can also take the exam and learn, take the exam and learn, take the exam and learn. So the good thing about the machine is machine can like do the high computational power, can calculate like thousands times, millions of times just in very quick time. So what you are trying to deliver here is machine can doing the repeating process, learning which variable is important, which pattern is important. After thousands of trying and learning, taking the exam, machine can figure out of 250 variables which is important, which variable set is important. That's the machine learning approach. So so that's the two approaches you guys have available right now. One is you have a theory first and you test the theory. Another one is you tune the machine learning model and trying to do the dimension reduction, and the machine can keep learning. Like I said, you can take the exam again and again. Machine can also take the exam again and again. Every time machine take the exam, machine can find out which part the machine did wrong, and machine can improve on themselves. So what's the pros and cons of the two approaches? The theory-based ones, the difficulty is you have to come up with a theory first, and you test it. Some theory is correct, some theory is not correct. So for example, I said the primary business income is better. It might be correct, it might not be correct. So you have to test it. You have to test it. That's the first approach. The machine learning approach, the downside of machine learning approach is it's very difficult to interpret. So for example, the machine pick up 5 variables are very important. Like the 5 variables together can explain the future stock returns. But it's very difficult to explain why the 5 variables actually can do the job. It's very difficult to explain the machine learning model at this stage. But what's the good thing? The good thing is the performance is pretty good. So the idea here is the machine learning approach can deliver a very powerful tool. They can tell you that which 5 variables together can explain the future stock returns. The machine learning model can do that in a very powerful way. But the problem is we don't know why behind. We don't know why behind. We don't know what's the theory behind. What's the theory behind that? And that's the trade-off between the two approach. So one is theory driven, another is machine learning driven. So for this class,